Yo, what's up? Good morning, good morning. So I'm hoping for a very productive day today. Hope we can fix all, or at least most of the to-dos related to applying the tessellation. I'm just gonna bring up the... Yeah, so I want to do... I want to refine this terrain selection marker for the new system. We want to fix terrain information, then we want to fix terraforming. Then we're probably going to add back... I want to fix terraforming both. I want to be able to add grass, and I want to be able to change the ground again. Then we're just going to refine the new weather, or the weather system, make it work with this new approach. And yeah, there's a lot on the to-do, so let's just jump right into it. So previously, the terrain, you pretty much focused separate terrain patches previously. This time around, we want to focus like the full terrain. So if we have the terrain, the focused part should be environment and not the separate terrain patches, because we're going to make all communication with the terrain go through terrain base script instead of the separate terrain patches. I think this is the better approach. So like, just an example. So previously when we hovered above or at a point in the environment, we did a physics raycast, or not raycast, but overlap sphere. And then we got all terrain patches that were within those bounds. And then for each terrain patch, we got all the data points that were inside of those terrain patches. This time around, we just ask the terrain base and it figures it out for us pretty much. Because it knows the stats of the terrain patches. We base the selection also on... We have a lot more information this time around when we create the selection, which means that we can work with separate... or that we can work with underlying data that is of different sizes and stuff like that. So yeah, I just think it's going to be a bit better overall. So let's see here now. Now, so previously we only had an action that was action terraform. This time around we have made it an interaction, which means that it needs something to interact with. So action, interaction, terraform. And we should be able to, so if we hover above... Can't I get the bug? So here, if we hover above the sky, we can see that our action interaction is available. If we hover above the ground, we can see that it's ready. And if we hover on the character, we can see that it's available again. Although... yeah, that's exactly how we want it. So now we just need to figure out... Let's take a look here. Tiny bit worried about the FPS we're seeing here, and there we go. Oh well. So what's happening is that it's ready to process, and then we want to call start processing when we start terraforming. And right now we start this one, terraform routine start terraform. And this one does shit like this. We're gonna implement a new method here, and we're gonna go through the full pipeline. So this is the pipeline previously. We get the terrain patches, we should terraform, filter them, make it into a list. And then we apply terraform brush for all of them, and then we update the terrain data. And yeah, this one was using terraform data, yes. We're gonna fix this. The end goal is to remove this one as well. So when we terraform, we will just fix the underlying data. But right now we're gonna need to have isMesh dependent still, because we need to, our height collider, which currently is just a mesh collider behind the scenes, still needs to be updated accordingly. But yeah, we'll see how we will fix this. So we're gonna try and figure out action interaction terraform. We don't need to do this. Instead, we are just gonna, terrain base is pretty much gonna handle most of the stuff for us. Where do we have that one? Terrain base, yeah. So we are just gonna send in, I'm wondering here. I think we just want to send in the terraform brush. And then we will get all the information from that one. So which makes me wonder if we're probably gonna make it threaded as well eventually. So our action interaction terraform, I wonder if, and then we don't need to make it into one of that. Maybe we do. We want to wait on something here. We will see. We're gonna make one of these, and I think everything we need to do here is pretty much interactable use. Yeah, the question is how I want to do this. Start processing, interactable pickup. It's an interactable use here. I wonder. We could just solve it like this for now. We're gonna want to animate. Yeah. Now we're just gonna do this. Interactable use. I wonder. Yeah, I think we're gonna do it like this. And check this if terrain base. We don't want to quit early here. But I think basically it's all gonna come down to base.terraform. And we just send in terraform. That is pretty much it. And then the terrain base is going to do the heavy lifting here. Do I actually have clear generator? Okay, nice. Actually did not know I had that one. Let's see if it works. Terrain base. No, we don't seem to be using them right now. Okay. Apply data, swap data, chance move data, clear data. All of those are going to be removed eventually. Generate. So something like this. Previously we used Terraform data and Terraform data row. I don't think we need that right now. was just an optimized way to do it on the CPU, make it a little bit easier to loop and stuff like that. Okay, we need a method to... Actually, we're gonna wait with this one sec. I want to get the... Terraform marker to work first, or Terraform brush visualizer to work accordingly first. But if we solve Terraform brush visualizer, we can use that solution for this Terraform eventually. We just need to take... So the problem is basically we want to given a world position in world space, we want to convert it down to position in terrain-based space, basically. But to visualize it, we can do that much simpler. Let's see. Action, interaction, terraform. We still want to do this if... maybe not. Or maybe. Toggle terraform brush visualizer. Yeah, here we go. Here, this is where we're going to start today. So show and hide it. Terraform brush visualizer. Let's add 2 functions like that. Show, avoid, hide. Just wonder if I want to do this. We might need to set some positions in here, stuff like this here. Let's see. So if this one gets called, the state has changed. So we know that if it's in state ready now, it wasn't previously. So what we can do then is we're gonna call, before we show it, we're gonna call I wonder if we want to call this one here. Now we're going to do this. Then we're gonna add set strength, set style, set type. So before we show it, we want to do something similar to this. Still gonna need to check this. I think we want to do and here we want to calculate these. Yeah, I think we're gonna leave it to terrain base to do this as well. So we have terraform. Let's see. Terraform shader, is it this one? No, it's not. Terrain marker, here we go. Grid delta, grid offset, yes. Okay, I wonder about grid offset. We might not need that one. So what I would like this one to do eventually is that I want to use our calculate grid best here. Original UV grid size. Line width. Original UV though, we can't really rely on this one unfortunately. Depends if we can calculate depends on if we can calculate. So these UVs, where do we get those from? We get them from the vertices themselves. Ooh. I don't know if we want to do that. I'm looking at the wrong shader. I want to look at marker shader, terrain marker shader. Okay. UV input position XY in screen space. Oh, do we do screen space UV? Yeah, because we want to get the depth. If we want to use grid best, we're gonna have to somehow create UVs. So I want to create UVs aligned with the ground pretty much. From in our disposal we have a sphere. Actually, yeah, we have a sphere, position OS. We calculate position in screen space and stuff like that. We actually don't return UV here, so we can skip this one. We don't use this one either. Rain-based data size. this one. But actually, world position. Yeah, if we get the world position, we can probably calculate some UVs from there. Yeah, we can probably use this one. But what I worry about is I would love if we could make this marker in such a way that we don't get grid marks on, so that we don't get grid marks on the character in question. Because if, okay, we calculate world position like this. Pixels on the character, we will still calculate a world position for them. I don't want to bring in the active texture in this shader. We shouldn't need that. From world position, we can get UVs based on the bounds of the terrain. Yo, what's up, Dead Revolver? So that shouldn't be a problem. How the hell would we go about not rendering it on the character? Without sending down the data. Is C# hard? No, I wouldn't say so. I think it's a pretty friendly language. But depends on what you do in it, I guess. Like, I mean, masking out other objects. If we feed... It depends on what we feed to this shader, like how hard and easy we want to make it. So best case scenario, I would like to not add or send down additional stuff to this shader. But I don't know if we can manage without it. Maybe we should just get the grid to appear first and we can worry about that later. So basically, world position, distance to sphere. Yeah, let's keep this one. World position, grid error, grid point, grid value. We're just going to replace all of this, basically. We're going to include... I don't know where we are. User interface shaders. shader utils, util helper functions. Added Revolver, I'm a 14-year-old kid trying to make a skill set, and I'm learning PHP, Ruby, Ruby on Rails, Rex, and Batch. Is it a good skill set? I have no idea. But I mean, for a 14-year-old, yes. I don't really dabble too much in, I don't know about Ruby though, but I don't dabble too much in web dev stuff. But when I do, all everyone talks about is, what is it, React, Node.js. In Rex you can make a high quality terminal game. Oh, that's nice. Calculate grid best, and what do we need to send down? We need UV, but not this UV. This UV right here won't give us anything. So we want to calculate something. World UV maybe. We'll send in world UV, then we want to send in the texture size, grid line width, and okay, if we only need to send in these. Yeah, we can fix this quite nicely, I think. So here we are gonna rename grid settings, grid visual. This one I still want. These two. I wonder, do we still need these as well? The distance to sphere and radius. We don't use radius. So when it comes to grid delta and grid offset, what I want to send in here instead is we want to add, so the things we need are data size. We're not going to send in down the data, we're just the related size of it. We need grid line width, this one we have. And finally position in world space. The only thing we need to send in apart from these two, we can probably do without sending these as well, is okay, I wonder about this one. Let me see. util helper function. We can probably do without this one, I reckon. We don't use this one anymore. Times grid size. Original UV we can calculate. But grid size here then should be equal to the full grid size. So let's say that we have, if we have a terrain that is 4 times 4 patches, we need to multiply grid size with number of patches. Yeah, let's try this. So to calculate the UV here, or world UV, we're gonna have to send down grid bounds, which we're gonna set to a vector, default 0, 0, 0. And then we need to send down grid bounds. It's not entirely correct. So basically I want the bounds in world space because I want to inverse lerp. So given our world space position, we can calculate UVs between 0 and 1 if we know the full world space bounds. I think we're going to do bounds, center, bounds, extent. And finally, we need the actual grid size. And with all of this, we can do the world UV is equal to lerp between inverse lerp between bounds center dot x minus bounds extent dot x plus, and finally position world space dot x. Then we just do the same, not for y, but for z. So then we have world UV, and then we just send in grid size as well. That should be it. We just need this one down here. I think that's everything we need. Bounds center, bounds extend, rain base. In here we have dimension. Do we have bounds? Terrain bounds. Yes, we do. And we also need full size. Patch dimension, patch count. Then it's only grid size left, which I'm a bit... It's going to be dependent on this one. Let's do awake, start, late, update on raw gizmo. Let's do it here. Public vector2 int get do it like this, and then we return rain patch count. Yeah, let's do patch count. But that's not, it's not going to be entirely correct, I don't think. Now we need to keep track of our overlap. We have three pixel overlap, I think. So patch count times type resolution. But if we do resolution here, it's 128 plus 3. I think... Fuck, do we want to remove all 3? I don't know. Giganto Mecha, what's up? Would you ever work with people on this game? Probably, eventually in the future. Not at this state, I don't think. Okay, I don't know how I want to do with this offset here. I'm a little bit worried about it. I think we want to do 128 plus 3. Yeah. Let's try this. So we do this, so that means that in Graph Brush Visualizer, we're gonna need to create some new ones here. Let's do terrain marker. These two are old. Bounce under bounce extent, grid size. Yeah, that's good, except for set grid property. So we don't need this. We need vector 3. Bounce center. Giganto Mecha, well, whatever you do, remember my name. I will. Extent, and finally vector 2 int grid size. Oh, yeah. Can we just do... Yeah. And we just need to feed this at the appropriate time. And we do that in action, interaction, terraform, and we do it here. Set grid properties. So then we have terrain base, bounds, I thought. Terrain base, terrain bounds. We can probably rename that one just bounds. Extends multiple. And finally, terrain base dot get full grid size. And we need to send in type here. Like now when I think about it, we probably don't want to do this here. We probably want to do... I'm gonna do it here for now. We probably want to do it here later on. Here, set type. Yeah. Then we're gonna have to fetch this one, which is gonna suck. Yeah, we can do it here. Then we do terraform brush dot type. So now we should send down the correct information. Let's see how this renders. If it renders at all. Float grid, we want to return something here as well. So I'm just going to return 4 times grid. Which, if it works, we're gonna get... Oh, inverse slurp, we don't have that. If it works, we're gonna get somewhat bloom around the grid. Not set to instance, that's not a good first sign. Game object focus event. Oh, fuck, do we have a get interactable type? Yeah, we might want to do some stuff first. Yeah, okay, I get it. We want to do action interaction, interactable entity. Interactable entity. Something like this. still getting the same error. Yeah, we are. If action state is ready, hands on. It should be available from the get-go. We shouldn't. Action interaction. Actually, let's say action. Awake start. Try set ready state. Is in state unavailable. Is in state processing. Are dependencies fulfilled? I get the feeling that we end up in action state ready, even though we shouldn't. Add dependency reference. When do we call this one? Animate entity. In start. Okay, we actually get to ready. Because we don't have any dependencies. Okay. And that's not good. Whoa, 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 whoa. Why? Add dependency reference. Why are we doing this so late? Add dependency reference should probably be... Yeah, it's just because I don't want to do get component. The fuck? We're gonna do it like this. Set up dependencies. We're gonna do it here, but it's gonna look a little bit different. And we're gonna remove this one. Try set ready state. Do I want to do it here or do we want to do it in a wake? I don't know just yet. Set up dependencies. No, not here. Set up dependencies, and I want to do for each action in... No, fuck this. I'm gonna do for each action dependency. For each action dependency in dependencies. Do I need to set up... Here we're gonna have to do... What I want to call this one here. Yeah, we're gonna have to do... I don't know if I like this. Action type. Here we would need to create a method that returns type pretty much. I don't know if that's... I'm not entirely sure how we would fix that. Like I would pretty much want, would do action. Because what I want to do eventually in action is for each action dependency, we want to do game object dot get component t, and here instead of t here, instead of this, I would like to get the type. Get type. Could send in game object and just do get component in the enum, but that doesn't feel too good. Yeah. Yo, good morning, PG King. Okay. I wonder if we could do something like this. Because I would like to do so public static string, not string, type, get type. I'm a little bit wary of this one, but default, and then it would be return type of. But we should be able to work with mono behaviors maybe. But type of action, interaction, collect maybe. Could this work? Game object get component action dependency. Action dependency dot action type dot type. It's weird, isn't it? Yeah, but it would look like this, and then component, but we need to know this. Yeah, we need to know this at runtime, or at compile time, I mean. So the easiest way to do this would be to just do it like this. How about that? I don't know, I don't know. So for pickup, and then we need game object here as well. Something. I don't know about this. Yeah, the problem with this is that we have sit and sleep, which are both use. I'm gonna have to think about this one. What we could do instead is this. I mean, this is at setup. It's not that bad. We could do... Yeah, if we do this, basically. Action available actions is equal to get components. We get all available actions for this one. And then we do something very similar to this. So available actions first or default, where action type, we just have it as type, yeah. Action type is equal to action dependency. What the fuck? Yeah, I need to clean this up. We can't have type here, action dependency, action type. So we have the available actions for the game object in question. We check it's this actions dependency. We get the first or default. If it's not null, we do set reference. Action dependency, set reference, available action dependency, action reference, state change, add listener, try set ready state. Yes, we don't want to try set ready state here. I think this should be the equivalent of what we did previously, but now we have it at a much better place. So when we instantiate an action here, we set state to available, then we set up dependencies. We define them in the editor. We go we fetch all available actions first. Then we go through each action dependency. If it's available, if available action, let's try this. Some extra calculations at startup, but I don't think it's too bad. We seriously still get the same issue. Yeah, I'm gonna have to double check that, but do everything else work? I want to double check. With this new way of setting up dependencies, focus, processing, action, interaction, inspect, it's available, ready. Okay, so dependency setup still works. So what do we have here? Action, interaction, terraform. Oh, have I forgotten to... Let's see. This should only be on ready. Interactable entity. Entity focus. Interactable entity is Oh, yeah. We don't set that one yet. Okay. Action, interaction, entity provider, interactable entity. Yes. We want to do entity provider. A private entity. Okay, let's see. Yeah, this is what we want to do. Think. Oh, we can probably get null from here. We'll see. Terraform ready, available, ready, available. Okay, that's good. I want to fix this sphere here. First of all, we have a few problems with it. It's not located at the correct point, and the material in question is pink. Do we have an error in this one? Yeah, we do. Let's see. Action, terrain marker. Unexpected token. Okay, we'll fix this one. Unexpected token. What have I forgot? Yo, good morning, Harukaran. Yes. There we go. Now we have something. Why can't I improve the size of this one? I think visually it looks pretty good. We just need to position it correctly. If we do 1, 1, 1. Yeah, we just need to position it correctly. And then I want to visually improve it as well, of course. To height, foliage, height. Currently we can't scale it either. We need to check that thing as well. Position and scale. Action, interaction, terraform. If we scale it, update terraform point radius. Change brush radius. We do brush radius with error margin. Brush radius. We have brush radius plus brush radius error margin. Set brush radius error margin. We never set this one. It's okay. I want to double check one more thing here, but before we do that, we just need to position it correctly as well. So this one right here, set brush position. Yeah, I reckon we want to do it here. Fuck, this might be... I wonder how I want to do this. When we want to update this position and not. It's ready to process. It's basically just when we're ready to process. Right now we listen on, so every time the pointer changes position, we call update terraform point. That's not really what we want to do. But, Yeah, we don't really care, so it's only the... Let's see here. This we might want to do at all times. Or I think the best approach would probably be to only like add and remove this one. So if state changed, so we change to ready. Then we start listening on input. If not, we remove the listener. Should probably be the same with all of these, but maybe. Yeah, I think we're gonna do it like this. Where do we have our entities here? Animate entity is grounded. I want to add is playable. I want something like this. It's actually virtual. Is playable false. Override bool is playable. if and here we just do this. Fuck, it doesn't feel too good. Maybe. And I want to put this in action, interaction, action. Try set ready state. Or is it enough with toggle terraform visualizer? What do I want to name this one then? It's so previously toggle terraform brush visualizer. This time around we're gonna listen to a lot of stuff. Fuck, we just want to do this. Toggle terraform brush visualizer. Yeah, we will only do this for playable entity. So we're gonna have creatures that run around with action, interaction, terraform that don't. Okay. Hmm. toggle something. I want to do something like this, I think. Now to the part not too fond of, but then we want to do something like this. We don't need to check for playable. Toggle terraform brush change. Update terraform point. And radius. Terraform strength. Terraform scale, style. A lot of this is temporary at this point. It's not really how the gameplay is gonna look with terraforming. But still, so let's keep this. And then of course, so when we start hovering above something that is terraformable, then we start listening to all of these inputs. And we're going to do some extra calculations here as well. When we're not ready to terraform, we remove all of this. Maybe. And then action, interaction, terraform. I just add this to every entity in the game that should be able to terraform. If we add it to the player, this one will be true. So in this case, we do toggle terraform brush change. Otherwise we don't. And we only instantiate the terraform brush visualizer if it's playable. Okay. So I just want to position this one correctly as well. Update terraform point. So now we're making the assumption that if this one gets called, we're in action state ready. I don't know. Which means that we're gonna do some weird checks here. But then again, update terraform point. This one we probably want to like these methods we probably want to call without this one. Doing the checks here for each of these, we can do this in a better way, I think. could add even more listeners. Or make this one listen to Terraform Brush. Or what the fuck? We should just do it like this, I reckon. Terraform Brush. Let's just do it in update. Because we enable and disable this one if it's visible or not, so depends on how demanding these will be, but Mm-hmm. It would be nice if this one is mostly self-sufficient. I'm just a little bit afraid of... We don't need to set this one, I don't think. Update if visualize terrain or visualize terraform brush. Return. Otherwise, set position, we're going to do some calculations for that one. Worry about these as well. Here we need to do this. These two we only need to set visualized terrain. Set these two here. But this one we need to change every time we change type. So we're probably gonna set it here. And we need type, so we're gonna do brush. Visualized terraform brush dot type. Yeah. And we do this. Okay, we do it like this. Just to make this one do as little as possible. So we don't need this. We don't need this. So here when we get a terrain base, we just do dot set visualize terrain base. And then here we instantiate it, and then we do dot set visualized brush, terraform brush. Like, I need to take a quick look at this one. How does this actually look? Action, interaction terraform. We have a brush and a possible brush visualizer. It's terraform, we have routine, we have terraform data, which we're probably going to get rid of. Animate entity. This one. Oh yeah, we want to disable physics and movement and such. Okay. So we instantiate the terraform brush. And then in start, we check if the entity is playable and terraform brush visualizer is not equal to null. So at this point, this is a prefab. If both of these are true, we instantiate the visualizer and we tell the visualizer to visualize this brush. And we also add a listener to a state change event for this action. Apart from that, we don't do anything there. Then we have these methods for changing terraform point, radius, strength, stuff like that. We want to do this, like for a playable entity, this should be changeable by the player. For a non-playable entity, just an animate entity, the entity script will handle, or the behavior script will handle this. And then we have this method. We only ever execute this one if it's playable. So it pretty much tells us that this action is now ready to execute. So if it is playable, we add a lot of these listeners, because now we want to start listen to the player input. And we also get for which terrain this is about. Okay, I wonder if I want to put this one at the top, actually. What happens if we try and remove a listener? We can't. Ah, fuck it. We get the terrain base in question and tells the terraform brush visualizer that this is the terrain. Maybe. So finally, before we try this again, in update here when we take the position. So terraform brush position. This one isn't truncated yet. Very important. So basically what we want to do here is we just get a point in world space. we want to truncate this point to position it in the center of grids. The center of grids, or the center of grid points, currently depend on what type of data we have. So basically, if we're terraforming, let's say that we have our foliage for the terrain is 128 times 128, and our height data for our terrain is 256, 256. So like when we truncate it to grid points, we're only going to get half the grid points for the foliage. And we want to visualize that as well. So this is the one we want to truncate. Did I remove the truncation in question? Yes, I did. Do we have... Trunk. Round, maybe. Okay, so one sec. I just want to take a look at how I did this truncation previously, because it worked pretty well. Action, terraform, let's see. I did something like this shit. Okay. Terrain offset. I don't think we care about terrain offset. Let's try and do it without offset for now. So we want to do transform.position is equal to, actually I would like, and we're going to do it like this. Rain base is actually going to calculate this shit. Get full grid size, terraform, public vector to get terrain point delta. And then we do return bounds, terrain bounds. Size, we can't swizzle here. Need to get terrain delta, get full terrain grid size, I would assume. And I want to have them close to each other. We're actually going to have them down there. Clear data, move data, swap, apply, generate. All of these are going to get removed. Occupy. Like this, get terrain delta. So transform position is equal to new vector 3. mathf.round. About new terraform point, terraform brush, or visualize terraform brush dot brush position dot x divided by visualize terraform brush type. And then we multiply this with no. Vector 2. Brain delta y, vision z. Something like that. Yeah, maybe. Yeah, that's right. I'm still a little bit worried about the size of the marker. It doesn't seem to be... It doesn't seem to be updating accordingly. 56. Mesh renderer, set vector, set visualize terrain. The fuck? Yeah. We do, or I do, set visualize terrain null. So we might need to do... Okay, no error, that is good. We can see our visualizer here. We actually get... We set it in the center of pixels. That's good, but we step way too far. Way too far. I need to double check as well. Terraform brush visualizer. Let's try and do... I'm a little bit worried. Are we... I want to double check if we're always at the center. Okay, so that's very good. Ooh, that is important as well. Is it? Okay, and then I want to check if we make it... Yeah, if we make it bigger in size, we don't change anything here. Do we... Character... We do debug, action, terraform. Here we have it. Do we have a brush? Terraform brush. Brush radius 0.1. We don't seem to be scaling the radius at all. I.e. Scalar event, scalar secondary event. No. Scalar event. This one never happens. Or I need to double check that one. Scalar event. Shift. It's actually this one. Yeah, we don't call it based on this one. Or I might know the cause of this one. Scalar event. Update terraform radius. Change brush radius scale delta. Sign brush radius delta change. Brush radius delta change 0. Brush radius range. Yeah. This one as well, yeah. We need to change this one based on... one sec, be right back. Okay, back. Unfortunately, I need to call it here. Which sucks. But we will continue this maybe tomorrow or next week. Fuck, bad place to stop. But yeah, thank you so much for watching. Sorry about the quick run, but have a great rest of the day. Peace.